Welcome to this deep dive into resolvers in Agent Studio. Today, we're going to explore how resolvers work. Resolvers act like interpreters for your plugins, taking everyday language from your users and converting it into specific data your plugin needs. Let's dive in. By the end of this video, you'll understand what resolvers do, the differences between static and dynamic resolvers, and how to set up dynamic resolvers with the right input arguments to enhance your plugin's functionality. What are resolvers? In Agent Studio, resolvers are components that fill slots. For example, a plugin to close a Jira ticket requires a ticket number as a slot. The resolver takes the user's natural language input and determines the correct data to fill that slot, ensuring accurate task execution. Another example, when a user says, "I want to talk to my manager," the resolver identifies their supervisor's ID or email. Resolvers are integral to Agent Studio's slots resolver system, which maps conversational language to structured data used by enterprise systems. This bridging ensures your plugins can interact seamlessly with business applications, making automation tasks like closing tickets or scheduling meetings more effective and user-friendly. Static resolvers rely on fixed, predefined mappings. For example, you might set a rule that maps HR departments to a specific ID like 123. Another case is a plugin checking PTO balances, where a static resolver maps terms like sick time or vacation time to specific codes. Static resolvers shine in simple, predictable scenarios where data doesn't change often. For instance, if your plugin always references the same department or a fixed set of Jira statuses like not started, in progress, or done, a static resolver is sufficient. However, they're less suited for dynamic, user-specific inputs. The downside of static resolvers is their lack of flexibility. They depend on preset rules that don't adapt to new information. For example, if a HR department ID changes in the backend, a static resolver won't update that automatically, potentially causing errors. This makes them less ideal for complex, context-dependent tasks. Dynamic resolvers are the heart of Agent Studio flexibility. They use AI and conversation context to interpret ambiguous inputs, often making API calls to external systems. For example, they can convert a vague request like "this week's most important bug" into a specific Jira issue ID, ensuring your plugin gets the right data. Here's how dynamic resolvers work in practice. If a user says, "reschedule the project I'm working on," the resolver might check the recent messages or project assignments to identify the current project ID. For "tomorrow's stand-up," it pulls the meeting ID from the calendar. The agent intelligently picks the best method, like fetching a Jira issue by ID for "update bug 732" or by user assignment for "update my task." Dynamic resolvers offer significant benefits. They adapt to different users and contexts, making plugins more robust and user-friendly. If an input is ambiguous, they can ask clarifying questions, like presenting a list of possible projects for the user to choose from, ensuring accuracy and a better user experience. When setting up resolver strategies, you can use one static method or multiple dynamic methods, but you can mix them or use multiple static methods. So let me show you how to configure dynamic resolvers and static resolvers. To configure dynamic and static resolvers, we gotta head to the Agent Studio app. So let's go ahead and do that. Now, you see that I have a process. This process is called update feature requests. And what we're gonna do is fetch feature requests and then update them based on the ones that I get. So if you go to the get feature requests action, I'm gonna test it to showcase you what feature requests I have at this time. So it looks like I have 2 feature requests, one for adding dark mode, one for improving load times. I have an ID, status, and some other information about the feature request. And then I'm going to show you the update feature request action, which contains 2 query parameters that have a feature request ID and new status. So basically, whenever we update a feature request, we require these 2 values. Now, let's go to our process. And what I want to do is have an activity for updating the feature request. Now, we see that we're still looking for those 2 fields, and those are probably going to have to be slots. One's going to be a dynamic slot resolver because we're going to hit an external system to find the feature request ID. And then also, I'm going to look into having a static resolver for this new status because the statuses are represented as code in the backend. So I'm going to go to slots, press create new, and I'm going to call this slot feature request ID. Slot description will be the feature request ID. And then we have resolver strategy here. So we don't have any strategies available, but I'm going to go ahead and create one. And I'm going to add a method here. This method is going to allow me to resolve for this feature request ID. Okay, so what I'm going to do here is I'm going to create a method which is going to be using the action of fetching feature requests. And I'm going to call that choose from existing feature requests. And then selecting the way to resolve it is going to be dynamic. Action is going to be fetch feature requests. So fetch feature request doesn't require any input mappings. I have the action hard-coded to myself. So it will just pull up my feature request. And then here in my output mapping, I can also dot walk to the place I want to dot walk, but actually, I don't need that essentially. I could dot walk to ID, but I don't really need to do that at this time. And then my output cardinality, you can either interpret the exact value or as a list of candidate values. In this case, since we are fetching multiple feature requests, we'll do a list of candidate values. Cool, and that's all we need to do. We press this X to save an exit, and our resolver strategy is set. I'm gonna go ahead and save. Now for status, we have to create this static resolver. So I'm gonna call this status, or new status rather, the new status of the feature request. And we're gonna head and go to resolver strategy as well, create, add a method, and we wanna call this something like new choices, select a way to resolve static. So you'll see that we have a list of options now. So the list of options that we have here can be compared between a display value and a raw value. The display value is going to be what we show to the user, and the raw value is going to be what we send to the API request. So in this case, if we have a status like limited preview, the raw value for that I believe is 11. And then let's say delivered, which is 8. Change the feature request to new, which is 1. And let's add feature consideration, which is 3. So if you have more, you can add more if you want. And then we're going to go ahead and click the X to exit out, and I'm going to press save. So now we have both slots. Let's go back to our action activity. Now, in our required slots dropdown, we're going to select both resolvers, or slots rather. And then the way to access this, we use the data key. So what we're going to do is click data dot feature request ID. And if you remember the payload from the action earlier, the ID field was called actually ID. And now for display value, it's going to be somewhat similar. We're going to do data dot new status. And then remember, there's a display value and a raw value. The raw value is called dot value, like this. Cool. We can also add a response output mapping, but we don't really need that since it's a post request or a change request rather. And we can add a key here. And that's how you set up slot dynamic resolvers and static resolvers. To wrap up, we explored how resolvers translate natural language into structured data, the differences between static and dynamic resolvers, and how to configure dynamic resolvers. Dynamic resolvers are key to building flexible plugins. Thanks for watching.